Hello, and welcome to the Paleontology class. In this class, you'll learn about dinosaurs, paleontologists and what they do, and about volcanoes. And then we'll play some fun games at the end. First, what is a paleontologist? Well, a paleontologist is a scientist who looks at and finds fossils or other remains from the past to get information about what it was like. They might look at dinosaur bones, eggs, footprints, nests, along with plants and insects that have turned into fossils. For example, if they find a palm tree leaf in Colorado, like this, then they might assume that Colorado used to be a tropical place because palm trees only grow in tropical places. Colorado seems like a very cold place right now, but it might have been a very warm place back when the dinosaurs lived. Here's some pictures of some other fossils they might find. Here's the palm frond leaf. Here is the seashell. And this is a dinosaur bone. Well, what exactly is a fossil? Well, a fossil is a trace of evidence of once living things, like dinosaurs or birds or old insects or plants in between layers of rock. That might be plants, fish, shells, animals, insects, or even footprints that aren't even alive. Some fossils form when minerals replace organic material over time. Fossils are one of the best ways for scientists like paleontologists to study the history of the Earth. When an animal, plant, or insect die, they get buried under layers and layers of soil. So let's say an animal dies right here. Then that animal is covered up by layers and layers of soil and rock. When the soil and rock is over them, the animal starts to decompose. That means that organic matter, like skin and flesh and everything, starts to decompose into dirt, which means to break apart. What's left of them is a hole. Between these rocks is a little hole that minerals and water begin to fill and soon harden. So this water full of minerals comes into this hole and fills it up. Then those minerals harden and it leaves a fossil for us to dig up and find thousands of years later. This is a diagram of that. So basically this little fish, he died, and then years later, he's covered up. You can see him here. And then this guy died. And then down here, you can see this guy is just bones now. And here's the original layer that was down here. And it's just adding layers and layers on top of them. And soon, this fish will become fossilized, and so will the other one. There are a few different types of fossils and ways that they can form. One of these ways is the rarest, is preserving the actual plant or animal in amber, or something like amber. This is a bee that was encased in amber, and this is from the time of the dinosaurs or sometime around that. And it is still the real thing. It hasn't been replaced by minerals. It is still the real thing, and it's been encased in amber. Another way a fossil can form is like the way we talked about before. It's when an animal dies and then it gets buried under layers and layers, and then minerals will replace the actual thing. So it feels like a rock. The last way, this is how the fossils were formed, like this. The last way fossils form is when an animal dies and gets buried under many, many layers. Pretty soon, the weight of the layers is so much that it pushes down on the things to imprint in the rock. For example, if I was to take a piece of Play-Doh and push my hand down in it, then it would leave an imprint of my hand. This is the same case, except instead of Play-Doh, we're imprinting into rock. Now, you might imagine that's very hard to do because when you put your hand on a rock, it doesn't just leave a handprint there. it would take a lot of weight on top to push that organic material into the rock. The water takes away the animal or plant after it's been imprinted in the rock, and it doesn't fill up the hole that it left. Instead, the minerals just leave it alone, and it's left with a mold. If you're interested in making these fossils, go to the bottom of the page on the website and click on the button that says Make Fossils, and I think the video shows you how to make a imprint or cast fossil. So this is a cast fossil, and this is the imprint, but this one was filled up. And then this is an imprint fossil of a seashell. As you can see, it just pressed right in there and nothing filled it up. You can find these along riverbeds and in the shale. And shale is a type of rock where lots of fossils like to form. Right now, we're going to do an activity. So if you have your egg that you made earlier and your excavation tray, you can go ahead and pause the video and hatch your egg and dig out your excavation kit and be like a paleontologist, which you just learned about. Now that you're back, we're going to learn how volcanoes form and exactly what they are. So volcanoes are geological features. Geological is a big word, but geo means rock or landscape. And logical means like the study of. So geological features on the Earth that are made by the heat under the Earth's crust. So the Earth's crust covers the whole planet, and inside is the core. The Earth's crust is just the very top of the Earth. So underneath the Earth's crust, there's a lot of heat because lava is down there. Lava and ash might take a little crack in the Earth's crust and start spewing out. Sometimes they even turn into islands, these volcanoes do. For example, in Hawaii, the islands are made of volcanoes. Volcanoes form when a crack in the Earth's surface starts to build up magma, and ash and layers become bigger and bigger. So this little bit of lava comes out and it's a little mound. Then ash comes out and it covers that little mound. Then more lava comes and it covers that mound to make it bigger. And pretty soon they add up until they're a big volcano. Here is the science behind a volcano. A volcano can be either active or dormant. Active means they are currently spewing out ash or lava or smoke. It doesn't mean constantly. It just means in the last few years. That means it is active. Dormant means that the volcano will never smoke, spit lava, or ash again. This could be because it no longer has magma coming from inside the Earth to feed it. Because if there's no magma coming under, the wind and the water take away and dig away slowly at the volcano until it becomes like a normal mound of earth. But how does a volcano work? Well, when magma bubbles up from below Earth's surface, it goes into a volcano. So, as you can imagine, the volcano is a cone, like how you made it your own volcano. Magma bubbles up from the bottom of the volcano, and as the magma rises, bubbles of gas form inside it. So there's all this tension because all this gas just really wants to escape. If the magma is thick, gas bubbles cannot easily escape, and the pressure builds up as the magma rises because more and more gas is coming in. When the pressure is too much, an explosive eruption can happen, which can be dangerous and destructive. Because as soon as magma touches something, it catches fire or burns down. Another way an eruption happens is when water underneath the surface interacts with the hot magma and creates steam. This steam can build up and it creates pressure, and just like when the gas builds up, it erupts. All right, so this is our volcano activity. Your volcano might look something like this, and this is what a real volcano looks like. As you can see, it's this mound, and the smoke and ash and lava is coming out of it. This is a very active volcano. So you're going to take the volcano you made earlier, and using a tablespoon of baking soda and a fourth a cup of vinegar, you're going to pour that right in the top, and then you're going to watch it explode. Now, all the stuff might not fit in there, so just a little bit at a time will work. You can also try baking powder and water, which will also create explosion. And you can also try citric acid and water. And then you can experiment with them to see which make the biggest explosions. Okay, so do that and then come back to the video. Now, after you've done your volcano explosion, it's time to learn about the last thing, dinosaurs. So here's some basics of dinosaurs. Dinosaurs were big reptiles that roamed the earth millions of years ago. You might know that. There were several different species that had different habits. Some of them were herbivores, which meant that they only ate plants. This picture down here is of only plants. Some were carnivores, which meant they only ate meat, down here. And others were omnivores, which ate plants and meat. That's right here. As you can see, meat and then there's plants. They had special characteristics that helped them live. But what's a characteristic? A characteristic is a feature of something that makes them what they are. For example, I walk on 2 feet and I have legs and arms and a face. So I'm a human. This is a T-Rex. Down here is a picture of a T-Rex, and it's one of the most famous dinosaurs because everyone knows the T-Rex is the scariest dinosaur. They had big, sharp teeth to sink into their prey because they are carnivores, which means that they need those teeth so that they can easily get the meat from their prey. They had long legs that helped them run to catch their prey, as you can see down here. And here's the sharp teeth. And they had a big tail right here that for balance when they're running, because if they didn't have that tail, they might fall forward. And they had tiny arms. Well, I guess that's their weakness, because their tiny arms really didn't do anything. Okay, now we have a duckbill. A duckbill has a long tail for balance while running, like the T-Rex, but it has kangaroo back legs for running and jumping away from a predator, such as a T-Rex. And the front legs could be walked on. As you can see, there's some kind of like hooves at the front, and those could be used to kick off other dinosaurs, and a sharp beak for cutting their plants because they eat plants. They are herbivores. Our next dinosaur is a pterodactyl. It has a P in front of it, but it's not pterodactyl, it's pterodactyl. They have a long, sharp beak for catching fish in the ocean, and they have sharp back talons for landing and catching the fish, like gripping onto them, because these are carnivores. They eat meat. And they have wings for flying and skimming the water so that they can catch fish from above instead of swimming through the water, because from above it's faster. Now we have an Apatosaurus. Apatosaurus has a really long neck for reaching leaves on really tall trees, because that's what they eat. They eat leaves. They're herbivores. And they have large round feet for carrying their lots of weight, and a long tail for balance to balance out that long neck. And they have long legs for running from predators. This is a Stegosaurus. It has plates for protection against predators right here. It has this little thorn at the end to swat away other predators and for defense. And it has a beak at the end of its mouth for cutting grass to eat because it's a herbivore. It has small front legs to run all fours or to run on two legs. That might seem crazy, but it can run a little bit on two legs before coming down. Now we're going to play the silhouette dinosaur game. So I'm going to show a silhouette, which is an outline colored in black of a dinosaur that we've learned about. And you'll try and guess what it is based on its characteristics. For example, if it has a long tail, we had 3 dinosaurs that had really long tails. We had the Apatosaurus, a duckbill, and a T-Rex. So it might be one of those. Ready, set, go. Silhouette 1 is this dinosaur. Can you guess what it is? It has plates on its back, a thorny tail, and a narrow head, which is pointy at the end. Can you guess what it is? 5, 4, 3, 2, 1. It is a Stegosaurus. Here's the next one. This big guy has sharp teeth, tiny arms, a long tail, and big back legs. Can you guess what it is? 5, 4, 3, 2, 1. That's right. It is a T-Rex. Now let's look at the next one. This has a small front legs, large back legs, and a big fat tail. 5, 4, 3, 2, 1. It is a duckbill. Now let's look at the last one of the last ones. It has a long neck, a long tail, round paws. Can you guess what it is? 5, 4, 3, 2, 1. It is an Apatosaurus. And our last one has wings, a sharp beak, and talons on its back feet. 5, 4, 3, 2, 1. That's right, it's a pterodactyl. Now we're going to play a game called the dice game. And basically, I'm going to roll the dice, and whatever it lands on, you're going to act like for 30 seconds around the room. For example, if I roll a pterodactyl, then you'd flap around like a pterodactyl around the room for 30 seconds. Let's see what we get first. We got a 3, which means we rolled a Stegosaurus. So you're going to act like a Stegosaurus for 30 seconds. Keep on going, we're almost halfway through. 5, 4, 3, 2, 1. There we go. Okay, now we're going to do that 3 more times. Let's see what dinosaur we get now. A 1. We're going to do a dinosaur of your choice. So you can do any dinosaur you want. You can do ones that we've learned about or ones that you just want to do. Ready? Set. Go. Okay, you're halfway through. Keep on going. Okay, we're done. Now, one more dinosaur. 4. So we're going to act like apatosauruses. 3, 2, 1, go. Okay, you're almost halfway there. Halfway now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Beep. Okay, now you're done. So now this class, you've learned about the characteristics of dinosaurs, what a paleontologist is, what paleontologists do, about volcanoes and how they work, and I hope that you had lots of fun. Goodbye!